Okay, so I'm making the video now. Yeah, I do. All right, so here's Miriam. She's going to read to you. Here we go. Okay, so I have to do detention, so I have all these detainees in here. And I need to get off the eraser.
Do I go? Do I go? Okay. A soccer ball sits on the ground motionless until you kick it. Your science book sits on the table until you pick it up. If you hold your book above the ground, then let it go. Gravity pulls it to the floor. In every one of these causes, the motion of the ball or book was changed by something pushing or pulling on it. An object will speed up, slow down, or turn only if something is pushing or pulling on it. A force is a push or pull. Examples of forces are shown in Figure 1. Think about throwing a ball. Your hand exerts a force on the ball, and the ball accelerates forward until it leaves your hand. After the ball leaves your hand, the force gravity causes its path to curve downward when the ball hits the ground. The ground exerts a force stopping the ball. A force can be exerted in different ways. For instance, a paper clip can be moved by force. A magnet exerts the pull of Earth's gravity on the force you exert when you pick it up. These are all examples of forces acting on the paper clip.
Okay, Miriam did a great job. All right, so we've already done our outline. We have Newton's first law, and we have our heading force. So remember we said we had a definition, okay? We have a force is a push or a pull. So we're going to write force, a push, or a pull. Okay, what are two other facts we can pull out of these two paragraphs? Okay, what's another fact, Miriam?
Okay, a force can be exerted in different ways.
Okay, so can be exerted in different ways. Okay, and the last one, a major force is gravity. By gravity is a force. Okay, very good. Now we're going to move on to the next page. Okay, so we have our first red heading. It's combining forces. We're going to read this. More than one force can act on an object at the same time. If you hold a paperclip near a magnet, you, the magnet, and gravity all exert forces on the paperclip. The combination of all the forces acting on an object is the net force. When more than one force is acting on an object, the net force determines the motion of the object. In this example, the paperclip is not moving, so the net force is 0. How do forces combine to form the net force? If the forces are in the same direction, they add together. Hang on, Joseph's going to say goodbye. He was in detention, but he found the Medici family is a patron of the arts. Now, what does Corey say? Boom! Oh, goodness. Okay, so how do forces combine to form the net force? If the forces are in the same direction, they add together to form the net force. If two forces are in opposite direction, then the net force is the difference between the two net forces, and it's the direction of the larger force. Okay, this is what we were doing when we had the arrows. Okay, so we have a definition. What is the definition? It is the combination of all forces acting on an object. Net force is the combination of forces acting on an object. If the arrows are going the same direction, we're going to add them. If the forces are going opposite directions, I can't draw arrows. You're going to subtract. And you've seen these, okay? Now our next heading is balanced and unbalanced forces. A force can act on an object without causing it to accelerate if other forces cancel the push or pull of the force. If you look at figure 2, if you and your friend push on a door with the same force in opposite directions, the door does not move because you both exert forces of the same size in opposite directions on the door. The two forces cancel each other. Two or more forces exerted on an object are balanced forces if their effects cancel each other and they do not cause a change in the object's motion. If the forces on an object are balanced, the net force is 0. If the forces are unbalanced forces, their effects don't cancel each other. Anytime the forces acting on an object are unbalanced, the net force is not 0 and the motion of the object changes. Okay, we have two definitions here. So balanced forces. Okay, we're not going to need to say two or more forces exerted on an object, but the effects cancel each other and they do not cause a change in the object's motion. Balanced forces. They cancel each other out. Okay, it's the same force in opposite directions. Okay, the object doesn't accelerate. No accelerate. I'm sorry, this is messy. We're not going to write that down. Okay, unbalanced forces. Okay. Oh, I have a C. All right. Balance, cancel each other, same force in opposite directions. That's fine. All right. So, unbalanced. Unbalanced. I can't spell. U-N-B-A-L-A-N-C-E-D. Okay, unbalanced forces. Their effects don't cancel each other out. Okay, don't cancel. Okay, so either different numbers, forces, or opposite directions or same direction. Okay, so balanced forces. The net force is 0. Okay, and for unbalanced forces, then you either need to add them together or subtract them. Okay, that was a lot of information, but this is stuff we've already done. Okay, now we have Newton's first law of motion. If you stand on a skateboard and someone gives you a push, then you and your skateboard will start moving. You will begin to move when the force was applied. An object at rest, like you on your skateboard, remains at rest until an unbalanced force acts on it and causes it to move. Because a force had to be applied to make you move when you and your skateboard were at rest, you might think that a force has to be applied continually to keep an object moving. Surprisingly, this is not the case. An object can be moving even if the net force acting on it is 0. The Italian scientist Galileo Galilei, who lived from 1564 to 1642, was one of the first to understand that a force doesn't need to be constantly applied to an object to keep it moving. Galileo's ideas helped Isaac Newton to better understand the nature of motion. Newton, who lived from 1642 to 1727, explained the motion of objects in 3 rules called Newton's laws of motion. Newton's first law of motion describes how an object moves when a net force acting on it is 0. According to Newton's first law, if the net force acting on an object is 0, the object remains at rest, or if it's already moving, continues to move in a straight line with constant speed. Okie dokie. Newton's first law of motion. Okay. Now, we've seen this written lots of different ways. One way is that it's called the law of inertia. Okay, which is an object keeps doing what it's doing. Okay, an object keeps doing what it's doing. Now, what is the net force for the first law of motion? Okay, for the first law of motion, the net force equals 0. That means we have balanced forces. You know what, let's write that on our C. Balanced forces. Okay, now we have our second subheading, friction. Galileo realized the motion of an object doesn't change until an unbalanced force acts on it. Every day you see moving objects come to a stop. The force that brings nearly everything to a stop is friction, which is the force that acts in what's that say? Something. Sliding between touching surfaces as shown in figure 3. Friction is why you never see objects moving with constant velocity unless a net force is applied. Friction is the force that continually brings your skateboard to a stop unless you keep pushing on it. Friction also acts on objects that are sliding or moving through substances such as air or water. So think about why, if things are out in space, they continually go. What is out in space? Is there anything out in space to stop an object? All right, so friction. We have one letter here. Friction is the force that brings nearly everything to a stop. Okay, you're going to want to pause it because I went ahead and wrote. All right, so pause the movie and come back when you're done. All right, so we have a subheading here, friction opposes sliding. Remember what I said about this page. It's kind of fluff probably, but let's read it. Although several different forms of friction exist, they all have one thing in common. If two objects are in contact, frictional forces always try to protect one object from sliding on the other object. If you rub your hand against a tabletop, you can feel the friction push against the motion of your hand. If you rub the other way, you can feel the direction of friction change, so it is again acting against your hand's motion. Friction always will slow a moving object. Okay, so friction will always slow. I'm going to pause it again. Okay, so pause it and write that down. Okay, now we have older ideas about motion. It took a long time to understand motion. One reason was that people did not understand the behavior of friction and that friction is a force. Because moving objects eventually come to a stop, people thought the natural state of an object was to be at rest. For an object to be in motion, something always had to be pushing or pulling it to keep it moving. As soon as the force stopped, the object would stop moving. Galileo understood an object in constant motion is as natural as an object at rest. It was usually friction that made moving objects slow down and eventually come to a stop. To keep an object moving, a force had to be applied to overcome the effects of friction. If friction could be removed, an object in motion would continue to move in a straight line with constant speed. Figure 4 shows motion where there is almost no friction. Okay, so we have an air hockey game, and this shows you what it's like when you have almost no friction. But people didn't always understand that. So it's important to know that friction was difficult to understand. And nowadays, it's very easy to know about friction and to understand it, but it wasn't always understood. Okay, now we're going to do the 3 types of friction. We have static friction. If you've ever tried to pushing something heavy like a refrigerator, you might have discovered that nothing happened at first. Then, as you push harder and harder, the object suddenly will start to move. When you first start to push, friction between the heavy refrigerator and the floor opposes the force you are exerting, and the net force is 0. The type of friction that prevents an object from moving when a force is applied is called static friction. Static friction is caused by the attraction between the atoms on the 2 surfaces that are in contact. This causes the surfaces to stick together or weld together when they are in contact. Usually, as the surface gets rougher and the object gets heavier, the force of static friction is larger. To move the object, you have to exert a force large enough to break the bonds holding 2 surfaces together. Now, I would like for you to see if you can find the definition of static friction and write that down. I'm not going to write it for you. You're going to find the definition of static friction. Okay? Find the words of static friction is called. Okay? Static friction is called. Okay? And you're going to write that for A. We'll do B tomorrow in class. Okay? Sliding friction. I would like for you to read the paragraph for sliding friction, and I want you to tell me what is sliding friction. Sliding friction does what? Okay, and you're going to write that down for A. Write this in pencil in case you make a mistake, and we have to fix it tomorrow. Okay, you're writing down one thing about sliding friction. What is sliding friction? Okay, and then rolling friction. Another type of friction, rolling friction, is needed to make a wheel or tire turn. Okay, so you're going to find what is the definition of rolling friction. And let's see. Yeah, I think you can find a definition of rolling friction in those 2 paragraphs. So read those 2 paragraphs and find a definition. So we're going to do this in class tomorrow, this in class tomorrow, and that in class tomorrow. But you are to have your own words written for 3A, 4A, and 5A. Okay? Have a good night. Go outside, and I'll see you tomorrow.